Hey everybody! Alright, it's time for review part 2. So, it's on to astronomy. We've gone over the basics of science and now we're starting the review for astronomy. So, the first thing on your review guide is the vocab for astronomy. There's not too many words here, but there's a few important ones. First of all, are two astronomers that we need to know. Ptolemy, you need to know Ptolemy, and you need to know Copernicus. So, Ptolemy, he believed the Earth was at the center of the universe. He believed Earth was at the center. Everything went around the Earth. He believed Earth was the center. And this was the most popular theory for 1,500 years in Europe. 1,500 years is a really long time. Copernicus, he's our second guy, and he believed the opposite. Or he believed something different. He believed the sun was at the center of the universe. He believed the sun was the center, not the earth. Copernicus here he is, with his stylish haircuts. He believed the sun was the center of the universe, and this revolutionized astronomy. Nobody believed him at first. No one thought he was correct. But it turns out he was correct. The sun is the center of the universe, and Copernicus was completely right. The next is some of our basic vocab. We have year, month, and the day. So, here we go. The year is the time needed for the Earth to orbit around the sun. If this yellow pencil here is our sun, and this red thing here is our Earth. It takes the Earth 1 year to orbit around the sun. 1 year is how long it takes the Earth to orbit around the sun. Alright, so besides a year, we have a month. Month is the time needed for the moon to orbit around the Earth. Remember, M is for month and M is for moon. Remember that moon starts with an M and month starts with an M. So if this is our Earth, right here, the moon takes 1 whole month to go around the Earth. The moon takes 1 month to go around. Our other vocab word is day. Day is the time needed for the Earth to rotate once on its axis. All that means is a day is how long it takes for the Earth to spin around one time. I know it's hard to see since this is so small, so I'm going to choose something else. If this here is the Earth, a day is how long it takes for the Earth to spin around one time. Like that. That's 1. That's 2. So remember, a year is all the way around the sun. A day is just the Earth spins around one time. Our last 2 vocab words are satellites. So satellites are natural or man-made bodies that orbit around something bigger than itself. So anything that orbits around, anything that spins around something else is a satellite. It can be man-made, which is artificial, or it can be natural, like the moon. The moon is a natural satellite. All right, important things to know. That's what it says next on that study guide. The formation of the moon, we need to know this. A giant asteroid, about the size of Mars, slammed into the Earth about 4.5 billion years ago. The moon formed in 3 steps: impact, ejection, and formation. 3 steps. Impact. Impact is when the Earth got hit. Impact. The second step, ejection, is when everything exploded off the Earth, when we had all these rocks coming off the Earth. After ejection, all the things coming off the Earth starts slowly spinning around and forming the moon. Formation is when gravity caused the debris, when gravity caused the rocks and dust to form and come together into the moon. So those are the 3 steps. Other important things to know: the life cycle of a star. All right, nebula is where it all begins. The nebula. All stars start as a nebula. Nebulas are giant clouds of gas. Here we go. I have a video of nebula here, if it'll play. Let's see if I can make it do it. Alright, so remember, nebulas, giant clouds of gas. Very beautiful. We'll go, there you go. See these giant clouds of gas. Clouds of gas and dust. That is a nebula. Alright, so after a nebula, we get a protostar. A protostar is when the gas begins to spin, and as it spins up, it heats up the center. And the more the center heats up, the faster it spins, and it lights up. Alright, so a protostar is when all the gas begins to spin around the center. And the faster it spins, the hotter it gets at the center. The hotter it gets at the center, the brighter this gets. And you have the very beginnings of a tiny star starting to form here in the middle. So after a protostar, we have a main sequence star. Our sun is a main sequence star. And this is when all the dust and gas have spun together to form a full star. This star is powered by nuclear fusion. After the main sequence star, we can get 2 different things. We can get a red giant or a supergiant. Red giant happens when we have only a smaller, bigger star. All the hydrogen gas is used up and it starts to grow, but it doesn't grow too big. A supergiant is when the star grows huge. As we see here, after a supergiant, we get a white dwarf. I'm sorry, bad Mr. Angling. After a red giant, we get a white dwarf. A white dwarf is a small, hot, dim star that is the leftover center of an older star. A red giant becomes a white dwarf. A red giant becomes a white dwarf. A supergiant gets bigger and bigger until it explodes. A supergiant becomes a supernova. A supernova is a gigantic explosion in which a massive star collapses. All that means is a supernova is a star exploding. And a supernova only happens after a supergiant. Alright, on to the planets. We need to talk about the planets. Alright, so the planets. Here we go. First planet next to the sun is... Does anyone know the answer? Well, I'm the only one in the room, so I'm going to have to answer. Mercury. Mercury is the first planet in the solar system. It is the smallest planet in the solar system. And the craters on Mercury were made by impacts. So Mercury is the first of the inner planets. The next inner planet is Venus. Venus, like Earth, is closer to the sun, and like Earth, it is an inner planet. But on Venus, the sun rises in the west because the Earth spins in the opposite direction. Oh, because the planet Venus spins in the opposite direction of Earth. The temperature on Venus is high because of the greenhouse effect. All that heat gets trapped on Venus because of its thick atmosphere, and it makes it very, very hot. After Venus, we have Earth. Earth is also an inner planet. Earth is the third planet from the sun, and it is good for life because of the water on the planet. Earth has the perfect temperature for liquid water. NASA scientists study the Earth with satellites. Alright, next planet we have Mars. Mars is the fourth planet from the Sun. It's a cold planet because of the thin atmosphere. And Mars once had water because we see evidence for the water in old lake beds. Alright, and those are our inner planets: Mercury, Venus, Earth, and Mars. On to the outer planets. The outer planets begin with Jupiter. Jupiter is our first outer planet. It is the fifth planet from the Sun, and it is the largest planet in the solar system. Jupiter's great red spot is a giant storm, and it is 3 times as big as the Earth. After Jupiter, we have Saturn. Saturn with the rings. Saturn is the 6th planet from the Sun. The radius of the rings is 60,000 kilometers. The rings themselves are made up of rocks, ice, and dust. And after Saturn, we have Uranus. Uranus is the 7th planet from the Sun. The axis of rotation is different from Earth because it spins on its side. So, a long time ago, the planet Uranus got hit by something massive, and that knocks it on its side. So Uranus is not spinning like this. This is how Earth spins. Earth spins up and down. Uranus got hit a long time ago, and it spins on its side. That's Uranus, the 7th planet from the Sun. And our final planet, our 8th planet, is Neptune. Neptune is the 8th planet from the Sun. And scientists thought Uranus needed to exist because something was affecting Neptune's gravity. Or something was affecting Uranus's gravity. And that was Neptune. A year on Neptune is 165 Earth years, which means it takes Neptune 165 years to get all the way around the Sun. And those are all the planets you need to know, and that is all the information you need to know about astronomy. Alright, you guys, good job and happy studying. Good luck on that final, and I'll see you for the chem review.